When I started this course, then I had mentioned that this course basically covers quality issues of material origin. That means the sources which are based on the material, not on the processing, which are causing quality problems. So, I am covering those aspects in this course. Now, I had mentioned that basically there are two broad origins for these quality problems. One is the poor cleanliness, that means exogenous entrapment or non-metallic inclusion. They are related to refining and continuous casting stages, continuous casting or ingot casting, but I am covering in this course mainly continuous casting. So, the poor cleanliness is one major source of exogenous entrapments, and then how it causes problems. I have covered different processes, the basic ideas of quality issues, and there it has been discussed that exogenous entrapment, particularly the larger ones, they are a very important source of the poor cleanliness and therefore an important quality issue. Now, there is another important origin of quality issues, that is basically the quality of the continuous casting. These are the exogenous entrapments which are taking place during refining or casting process, but now I will start talking about the quality of the casting. What is meant by the quality of casting? Basically it may be at the surface of the casting, it may be at the subsurface level, or it may be internal position of the casting. Why this is important? Because the casting, when we have to finally roll it, hot roll it, and subsequently maybe cold roll it, or we have to hot forge it. So, during that processing, whatever quality problems are there, whatever cracks or subsurface cracks are there or internal cracks are there, they might come to the surface. So, that may constitute an important quality issue. So, today and on subsequent presentations, I will be talking about quality of casting, what are those and the different issues of that. So, this quality, they are related to specific grade and casting process. There are two issues. One is the grade, steel grade which you are casting, that is important, because certain quality issues are inherent to the specific steel grade, and some are basically related to the casting process as such. So, both are important. We have to keep in mind first the steel grade as well as the casting process. Yeah. So, let me start with this quality issues in continuously cast product. So, it can be surface, it can be internal quality as I was mentioning. So, now what is important, what I will be covering is what are the types of defects, what are the type of quality issues, the influence of chemistry on solidification as such. Why chemistry is important? Because it controls the solidification sequence, how solidification takes place, whether it is delta or it is gamma, at what temperature delta gamma transformation takes place, all these issues. Then another very important issue is the segregation. Why segregation is important during solidification, how it is related to the quality problem, this I will be trying to discuss. Then another important issue is the strength and ductility of solidifying shell. When steel is being continuously cast, solidification takes some time, it does not occur instantaneously. So, during the stage of solidification, the solid shell is forming, in between there is a mushy zone, that means solid plus liquid, and then there is a liquid. So, the shell is one aspect, then there is a mushy zone, and finally the liquid. So, what is the strength and ductility of the solidifying shell, this also I will discuss, because this is very important to understand, because at what point of time, at what temperature, at what stage of solidification cracks will start developing, whether cracks will start developing even after solidification during the time of cooling, this is very important. So, strength and ductility of the solid shell is very important. Then I will be talking about the cast structure. Cast structure basically means dendrites. All of us know that we will be talking of the dendritic solidification, that means what is the size of the dendrites, what are the distribution of dendrites, what is the different zones of cast structure, whether it is equiaxed, whether it is columnar, what is the size relative fraction of columnar vis-a-vis central equiaxed. All these issues are very important, because if we do not understand that, we cannot know why cracks will form, at what stage crack will form, whether they are at the surface, whether they are at the subsurface location, or whether they are interior at the central portion of the casting. All these are important issues. Then of course, influence of casting parameters, that means casting speed, superheat, these are very important issues. What is the type of powder you are using, that gives us what is the heat transfer in the mold. The primary cooling takes place in the mold, continuous casting mold. So the continuous casting parameter, rather the powder which you are used, which will get melted, and finally the slag is generated, mold slag. So the mold slag will finally determine the heat transfer characteristic for the primary cooling. So that is very important. Then the secondary cooling means when the slab or bloom or billet is coming out of the mold. So up below the mold, it is the secondary cooling we call it. There is a direct cooling by water or mist, air mist. So there in the secondary cooling, what should be the cooling intensity, whether it should be more or less, what is the uniformity, how does it come down. So all these are very important issues as far as quality of the surface and internal portion of the cast product is concerned. And now why cast product is important, because after all the cast product we will be rolling, we will be forging it. So finally whatever product we get, the final quality in the product will very much depend on the quality of the cast product. So that is why we are interested in the quality of the cast product. Now let us try to understand what is happening during continuous casting. This is very important to understand. I think first this area is called the mold. This is a water cooled mold, and we are pouring the liquid still from the tun dish to the mold, inside the mold. So this, the surface level is called the meniscus. What you can see, you cannot see this portion of the, while the casting is taking place, you can see only the meniscus, which is the surface. On liquid steel, on top of that you have, as I have mentioned in the earlier session, we have molten slag, which we call mold slag, and on top of that is the powder, from which the powder melts and the slag is generated. So we have first the powder on the top of it, beneath that is a maybe solid liquid stage, semi molten powder, and beneath that, below that is the molten slag, and afterwards still below of course is the liquid steel. So this liquid, this yellow portion is the liquid steel here, and then the solidification starts just below the meniscus itself, because there is cooling, there is a heat transfer is taking place within the mold. So heat is getting extracted this way. The mold is water cooled, that means heat is getting extracted in the horizontal direction. So as you are coming down, the solid shell, this red portion is the solid shell. The width of the solid shell, thickness of the solid shell is increasing as you are coming down. That means lower we go in the casting direction, thicker is the solid shell, which is expected because more and more solidification is taking place in the mold. Therefore, the solid shell is increasing in thickness. This is important. And then when it is coming below the mold, that means when it is coming out of the shell is coming out of the mold, then what is important is the shell thickness is very important. Otherwise there is a ferrostatic pressure, this is liquid. This liquid will put lot of pressure on a solid shell. So when there is a mold is the support for the shell. But when the shell is coming out of the mold, what is the support? There has to be some support. So there are rolls, these are the rolls which give the support for the shell to the solidifying strand both the sides. So, the support of mold is support of rolls, support from the rolls, these are all moving rolls, they are not static rolls, they are moving rolls. It also gives an vertical downward velocity to the shell, that is important, to the strand. Strand means everything, the shell, then the mushy zone as well as the liquid, this whole thing is called strand. This one is the solid shell, then you have mushy zone, these will be coming one after another, and then you have liquid. So, this is very important. Finally, as you are coming down, after certain distances, the whole solidification is over. So, this is the final solidification location. So, solidification is starting in the mold where there is primary cooling, these are copper molds and these are water cooled. So, heat flow, heat direction is taking the heat which is inside the liquid still away from this direction, horizontal direction. We are assuming that there is not much of heat flow in the vertical direction, because why? Because we have a slag here and on top of that you have powder. So, we are assuming that heat flow is taking place only during the horizontal direction. So, that is why the solid shell is increasing in thickness as you are coming down. Now, the below the mold again the solid shell is increasing, but here there is a possibility of solid shell getting bent, because there is not much of support, there is not continuous support, and the solid shell strength is also important here, how much bending will take place, all these are important. And in between these rolls you have water spray, this is the water spray, here in between the rolls. It may be water, it may be mist, air mist. Mist is basically combination of air and water. So, this either water cooling or mist cooling, this is known as the secondary cooling. Primary cooling is occurring inside the mold. Below the mold it is called secondary cooling. So, certain amount of water or mist is necessary. So, how much of water, so what is the cooling intensity, that is very important, because at what point you want the final solidification is dictated by how much of secondary cooling you will be using. What is the intensity of secondary cooling? What is the intensity here, what is the intensity down, because as you are going down, that means you are requiring less cooling, because here very high amount of liquid still is there, as you are coming down mode of solidification is taking place. So, you require less and less cooling. So, cooling intensity is very high here, secondary cooling intensity, less here coming down as you are going down. So, this is very important. Now, I have mentioned here this, look at this. So, this is what is known as ferrostatic pressure is given by the liquid still. So, whatever liquid still is inside the strand, inside the caster, that will put ferrostatic pressure on the shell, solid shell which is forming. So, the pressure is 0 here, as you are coming down pressure is increasing. So, after solidification is complete, there will be no pressure of course, because there is no liquid. So, this is the indication, the pressure is starting from here and it is increasing till solidification is over. This is called ferrostatic pressure, this is a ferrostatic head is increasing. As you are coming down the head is increasing, so pressure is also increasing. This also plays a very important role in continuous casting. So, on the solid shell there is ferrostatic pressure, this is very important to understand. Now look at here, this is this portion which has been put here. So, this is the shell thickness, on shell there is internal pressure which is called ferrostatic pressure, whatever is shown here. So, the pressure is dependent on the density and the height. Height means this is the height, as you are going down the pressure is increasing. So, that is what is important. And the material, after all, what is it? This solid shell. So, the material properties, the high temperature property of the shell is very important. This we will discuss in details whenever solidification is taking place. How the solidification will take place, it depends on the chemistry of the steel. It may solidify through delta, it may solidify through delta plus gamma or through gamma. That means, it may solidify through delta ferrite, it may solidify through austenite, depends on the chemistry. All these I will discuss in detail, so you will come to know. So, what is important is the property of the shell is very important. Property of the shell is dictated by what? Dictated by whether it is delta or gamma or delta plus gamma, or what is the shell thickness, whether it can resist the internal pressure. This is very important. So, material strength is important, surface temperature is important, because as the temperature is coming down, the strength also will change, the ductility will change, toughness will change. So, temperature is important, whether it is delta or gamma, that is important, and internal pressure is important, like as you are going down, pressure is increasing. So, all these are important issues during continuous casting. So, the distance between the two rolls, it is called roll pitch. This somewhere this is not coming out very clearly, but it is called the roll pitch. That means the distance between the rolls is called roll pitch. It is not uniform. As you are coming down, the shell is increasing, shell thickness, that means you do not require so much of support. Here you require more support, so the pitch will be less. As you are coming down, pitch may not be required so much, because already the shell is quite thick, too much of it can resist the pressure, so too much of support may not be necessary. So, these are all important issues. Yeah. So, now this I had discussed earlier, that there can be two types of mold. This I discussed with respect to the distribution of the inclusions in mold, but here try to understand what is happening. If you have a straight mold, the mold has to be first bent and then it has to be again straightened to make it. Here it is vertical, finally you want this shell, solid shell should become horizontal. We are showing only the vertical portion here, actually it is not vertical, it is trying after below the mold, it is slowly bending. So, that is what is important, you have to bend it, the strand has to be bent. So, first a bending is necessary, we call it bender. So, when we are bending, try to see what is happening here. This is the inner radius I have mentioned earlier. So, this inner radius portion is having a what type of stress? It is a compressive stress. Here outer radius during the bending, this is a tensile stress. So, you just see this is not uniform because of the bending. Everything was uniform when it is vertical, again everything will be uniform when it is horizontal, but in the process of bending, inner radius, this is the inner radius of the caster, there is a compressive stress on the shells in this portion, there is a tensile stress, and in between there is no stress at all. So, and then first there is bending. If you have a carved mold, there is no bending, because the strand itself is such that the mold, here the mold is vertical, but here if the carved mold is there, that means mold itself will be carved. So, the shell which is coming out of the mold is a bent, is not vertical like here. So, there is no bending necessary additional, because the bending has started in the mold itself. So, what is necessary here is straightening. Here straightening is necessary, here also straightening is necessary, because finally it has to be made horizontal, otherwise what will happen? It will go on like this. If you do not use straightener, then what happens? This mold will get like this, it will bend like this, because it has started bending. Here you have given a bending, so mold will be like this. To make it horizontal, some straightener is necessary. Straightener means you have to put some additional pressure here, so that it becomes horizontal. So, while bending, inner surfaces becomes or gets compressive strain, but during straightening, here the inner surface layer is getting the opposite, it is getting, here it was compressive, here it is not, here this outer portion is compressive, here it is increasing in this direction. You just see the reverse. So, what is important is try to understand that the shell is getting a lot of mechanical strain during solidification. It is unlike ingot casting. Ingot casting, it is the shell after it has solidified, there is no additional strain. The shell is not moving, it is static. Here the shell is moving, solid shell which is forming inside the mold. It is not static, it is coming out continuous, it is in continuous movement. Still the whole thing gets solidified. So, a portion of it is getting lot of mechanical strain, that is important. Inside you are getting lot of internal pressure, ferrostatic pressure. Then the shell during solidification, there will be some what is that called? When the solidification takes place, there is a shrinkage. When delta to gamma transformation takes place, again there will be shrinkage. When the temperature of the shell is coming down, again there will be thermal stress. So, the shell is undergoing lot of stress. I will discuss in details everything. So, what is important to understand is that the solid shell is not static, it is under movement, it is undergoing lot of stress. There may be ferrostatic pressure from the liquid still. During bending, during straightening, there are a lot of pressure on the surface, on both the surfaces. This pressure, this tension or compression, here it is tension at the straightener, this tension, and at the outer surface it is compression, and in between it is nothing. Internal stage is basically in between, they will be balancing one another. So, tension at the inner surface, compression at the outer surface, in between there is nothing. So, we have to understand, for a straight mold situation is more complicated because first there is bending and then there is straightening. For a curved mold there is only straightening, so relatively less internal stress here, but nevertheless there is internal stress at the surface, at both the surfaces. The nature of stress will be different. So, what is important is to understand the shell is undergoing lot of pressure, lot of stress, lot of strain. So, the property, high temperature property of the shell, solid shell, is very important. It should withstand all those strains, otherwise there will be crack formation. That is what is important to understand.